This video we are going to implement a polygon, which is supposed to be filled with red color, of color code hash FFF000. And I will continue like as usual. My Vulkan I've set up in the my hello vk.h header file. I've set up my methods over here. The method like I never touched on is like the method of create logical device and queue, create swap chain, create image views, and create render pass. So like the method of create logical and queue, this one method it's like create logical device and queue. It's like a physical device. When you select it, like this function, you see this function is used to create the logical device. And we all know that the logical device are used in the representation of the interface, that when you want to interact with the physical device. Also, this function over here, it ensures that when you want to like create a queue, like, and submit let's say commands to the our hardware, the GPU, this function over here is responsible for it. Also, the create swap chain over here, it is like a type of method that, like, it is a collection of image buffers, and they are used to displaying rendered frames onto the surface. And the function, like, it works by creating a swap chain. Like, we all know the swap chain is crucial for presenting images to the screen. And also this create image views over here, it's a way to interpret the images with the swap chain. And this function, the main work is to create image views for each image, like in the swap chain, and allowing them to be used as render targets. And create render pass is a type of a series of operations that will be performed during the rendering process. And it defines attachments, and that the attachments, like the color depth here, use them to define what type of color you want, the depth. And also the function, it creates an object, which is a render pass object. And this method over here, create descriptor set layout, is a layout that define the layout, is a set of layout, that define the layout of descriptor sets. The descriptor sets are used for binding resources like the buffers, textures, to the our shader file over here. And it typically creates descriptor set layouts. Yeah. And we have another function over here, which is the create graphics pipeline. The create graphics pipeline, it defines the sequence and operations occurring during the rendering process. Like, it includes vertex processing, if you want, like, fragment shading and blending. This function over here, it is also responsible to create graphics pipeline object that encapsulates the configuration of these operations. We also have the create frame buffers. The frame buffers typically are used to represent a collection of image views that serve as render targets for rendering operations. Also, they are used together with the render passes that I told you, that are created over here by a render pass object. And typically what these functions do is that it creates frame buffers for each image, in the swap chain. Also, we have the create command pool. It is used to like a memory management in buffers. Yeah, like memory, like in C and C, these low-level system languages, that memory management is key when you are writing your programs, to ensure that you save on memory usage, like when, like, all no, even the local variables, they are stored where they are supposed to be. Like, also in this freeing up of memory and allocating of memory. Typically, this is what the create command pool is used for. We also have create command buffer. The create command buffer contains commands that will be executed on the GPU. Also, we all know that this function create command buffers and record rendering commands into them. like it is specified what operation should be performed during rendering. Also, lastly, we have our function here, create sync objects. It is used to coordinate operations between the CPU and the GPU, ensuring that the rendering commands which we defined up here, that they are executed in the correct order, and the resources, since this is a C language, the resources are accessed safely. This function, it ensures that it creates synchronization objects such as semaphores and fences. All the semaphores is a concept, fences which you learned in the previous unit of systems programming. Now, like when all these functions here complete, then the Vulkan initialization is done. Yeah, and here is where the initialization happen. This is where all the functions that I have defined up there, they are initialized. Also remember that each method here has its own like parameters over here. Like this one is the create buffer, it has its own parameter up to create, up to setup, create, let me check, up to all the way up to, also you have create swap chain over here. They are defined as void hello vk. Yeah, a create swap chain. Like I understand this is like a sort of an object for accessing the, not an object, sorry, it's like accessing the methods up there. I've forgotten the name for it's called, but I will search it. Also, up to all the, you also see we have here create graphics pipeline up to create sync objects. Now we'll go to the shader.frag. Typically that's the whole introduction. This here, the whole of this is the one used in the all our next questions that we are going to cover. Like all of this is how the Vulkan initialization is done. In the shader fragment, okay, in the shader vertices, we have defined vertices of an array of 6. 1, 2, 3, 4, 5, 6, each of position 0.5, 0.5, 0.5, 0.5, negative 0.5, yeah. And the colors for each vertex, which is 6, the colors for each vertex is red, which is color code 1.0, 0.0, and 0.0. Also here is where the initialization happens. So I'm gonna initialize, like since the question was about to create a program to draw a polygon field in color red. Now I'm gonna run it. It's building. Yeah, as you can see, our polygon is here and it is filled in a red color. I'm doing this from I've screencast my Android, as you can see, in my Android Studio.